These questions you don't have to write down because they are exactly the same as the questions on the sheet that you did on Thursday. The solutions you already have, but I'm going to work through them again, and I just want you to watch because you already have them on this paper. I just want you to watch and think about it, and hopefully you read through that as part of the efforts on Thursday so that you're ready for it right now. Question?
What about the last one on this? What is the thing that was over here? Okay, I can't see it.
This here?
Oh, is that log 6?
Minus log 6x because I just moved it to the other side. Okay. So now we are going to look at solving for x in an exponent, right? And there's basically, so this is solving an exponential equation and I'm going to split it up because we already did the non-calculator part when we did section 5.2 and 5.3. Right? If it's non-calculator, we want to use our powers chart, and the idea is you just need to get your bases the same. If you had something like 5 to the x equals 5 to the 3, you could be like, so x equals 3. That was the non-calculator part. The non-calculator part only worked if we could use our powers chart and there was something in the same column that you could write a power on both sides with the same base. But often we get these questions where like, oh, 3 is definitely not in my powers chart for 2. And so I can't use a non-calculator approach, so I have to go to a calculator approach. And the calculator approach says, well, what's the opposite of an exponential? What's its inverse? Its inverse is a logarithm. So the calculator approach says, okay, well then I need to take the log or the natural log of both sides. Okay? And I'm going to show you this. There's some other techniques as well. Some of you might like them, but this is going to be the technique that works all the time and works the best. So what does it mean to take the log or natural log of both sides? It's exactly like that. I take the log of this side, I take the log of this side. That'll be step 1. Once I've done that, this is all in your notes already, so you don't need to write this down. Okay, you have all of this, so I want you to watch. Once you have that, we have a log law. We want to solve for x. The whole reason we take the log or the natural log of both sides is it allows us to bring exponents out in front. So at this point, I can bring that exponent out in front, and I would get x log of 2 equals log of 3. And I can divide both sides, and I can go to my calculator slowly, and I'll be able to write the final answer. And I want to show you something on your calculator that is very helpful and very important. Lots of students love solving log equations because once they put in their answer, so here I had log 3 divided by log of 2, and I got an answer 1.585. Answer correct, 3 decimal places, always 3 decimal places. Now, I want to know if I got it right. I'm going to tell you that if you use your store button and store it as x, you can check. My original equation had 2 to the x. And what is it supposed to equal? 3. If I push enter here and it equals 3, I know that I've done my work right and my answer is completely right. If I get something else, not so much fun, I know I've made a mistake somewhere and I should check my work again. But students love these questions on the calculator part because you can get your answer and you can check like an answer key. Wouldn't it be nice if your test had an answer key, especially for the multiple choice? You're like, oh, I think I meant C. Right? That would be marks on the multiple choice. I'm sure would go up a lot. Right? On long answer, you still lose. You could still lose marks because you're like, yeah, you just wrote the answer down. You didn't know what you were doing because you didn't show any work. So we can always check, which is really, really nice. So if you take the log of both sides, okay, then it changes it into a form where it's log over log. If you did natural log, you would have got natural log of 3 over natural log of 2. Using log or natural log, all the work would be identical. And sure enough, if you go to your calculator, and we've seen this before, but if I would do natural log of 3 divided by natural log of 2, I get the exact same answer. So when I say you can take the log or natural log of both sides, it really doesn't matter. So, next one. We've got a little bit more stuff to work with. And you can do this in one of 2 ways. I'll first do it exactly the same as I did it in your, well, I think if I remember correctly, I did it in the notes that you had on Thursday. If you took the log of both sides. Students are tempted at this moment to make a mistake. You are so excited about getting that x out in front of the exponent that you want to do it right away. But if we look at our log law for the exponent right over here, we can only use these log laws exactly as they're written. If there's something a little bit different in the log law, you are not allowed to use it. So in the log law with bringing the exponent out, notice that the n is the exponent to m. That's the only thing inside the logarithm. There's no extra numbers. Then I can bring that n out in front. In this case, we have an extra 2. Okay? Also, I mentioned this before, you will be tempted to break your order of operations. See how this 2 times 3 is there? Some of you are going to be tempted to say, oh, I know what 2 times 3 is. It's equal to 6. But your order of operations say you have to do exponents before you multiply. Is this x an exponent also to the 2? No. That x is an exponent only to the 3. So before we can bring this x out, that can be the only thing inside of a logarithm to bring it out. You do have a log law that says if I multiply, I add. And now, this x is the only exponent inside. This would be allowed to be brought out in front. Okay? I'm going to, move the log 2 by subtracting on both sides. And then, how do I get x by itself? The opposite of multiplying would be to divide. And type this into my calculator. Log of 5 minus log of 2 all divided by log of 3. 0.834. I'm going to store that as x, and I'm going to check, what was my original question? 2 times 3 to the x? 2 bracket 3 to the exponent of x. If this is equal to 5, then I know my answer is completely right. If it's something else, I've made a mathematical error somewhere. I'm nervous. Right before I push enter, there's a little bit of nervousness thinking, what if I did it wrong? So again, really nice. Oh, I didn't want to close that. It takes forever to open up. Or did I close my... Oh. No, I didn't close it. Just close it. So, can solve it that way. Okay? Another thing that sometimes, and we're going to use this strategy, especially when we get into complex word problems, a strategy that sometimes is possible, and it works in this one, is if you can get your power by itself early. And in this case, I can, right? There's my power, it's 3 to the x. Could I get that all by itself on one side of the equation? Absolutely. I have to divide both sides by 2. If I divide both sides by 2, leave it as a fraction, or you can change it to 2.5, then it looks like this. Getting the power by itself, then taking the log of both sides. Now I can bring my x out right away, right? I didn't have to worry about this extra step of having to use a log law that adds first before I bring it out. And I would get x log 3 equals log 5 over 2, and I could divide. Can you see that these steps here and here are identical? Because what's your log law for dividing? Subtracting. Log 5 minus log 2 is the same as log 5 over 2. But sometimes if we take that extra step at the beginning and get our power by itself, it makes our work with logarithms a little bit easier. We didn't have to do this extra log law, okay? But I can tell you that students get in their head solving an exponential equation. I have to take the log of both sides. Well, if you take the log of both sides early, like we did here, it's still doable, but you just have to do one extra log law. If you divide it first, you save yourself a log law if you get the power by itself to begin with. And then there's the most complicated ones where we have x's on both sides. There's no way to get a power by itself. This one, just for fun, I'm going to use natural logs instead of logs. Well, not just for fun, for 2 reasons. One is every time you write natural log, you only have to write 2 letters instead of 3 letters, so it saves you a tiny bit of time. Plus, in calculus, you're going to use natural logs a whole much more than logarithms, so may as well get used to it.
Is there any difference?
Yeah, well, a log has a hidden base, and a natural log has a hidden base. What's the base of a log? 10. What's the base of a natural log? E. The number E. So technically, natural log of x is exactly the same as log base E of x. And the number E is so important that it gets used so much. So when we write a log without a number, there's a 10 there. When we write a natural log without a number, it's actually a log with a little e there. So if I take the log of both sides, this power could come out in front. This power can come out in front. bring that power out, since it's a binomial, we have to bring it out in brackets. Forgetting those brackets makes it equal to something totally different. The whole power comes out in front. And since natural log of 5 and natural log of 3 are numbers, you can distribute them. So now our job is to see if we can solve for x. I'm going to get rid of the brackets of x natural log of 5 minus natural log of 5 on this side, and 2x natural log of 3 on this side, plus 3 natural log of 3. And if I want to solve for x, I'm going to want to put my like terms together. Here are my terms with x's. I'm going to put those on the same side. So I'm going to have x natural log of 5 minus 2x natural log of 3. And I'm going to move all my just plain numbers. So I'm going to add the natural log of 5 to both sides. And if you have x's in two exponents, like we do in this case, we get two terms with x's. In order to get a single x, we would say, hey, if I have two terms with x's, that's a common factor. I can take out that common factor. And then to get x by itself, I just need to divide. So by using natural log in this one, how many letters have I already saved? 18 letters. It's like almost a second of work saved. So if you don't like natural log, you can use log. It's not going to be that much longer. And again, once I have this final answer, I can go to my calculator. And type the whole thing in. Negative 8 point, again, 3 decimal places, 8345. And again, I'm going to check. I want to know if I got this answer right. But in my original equation, there's the original equation, I have x's on both sides. So I can check by doing 5 to the power of x minus 1, that's the right-hand side. And I can do the same thing, 3 to the power of 2x plus 3. And if the numbers are the same, then you know you've got it right. Yep. So we're able to check it to see if we're able to get it right. So again, all of these ones were in your notes, right? From the most basic one, just a simple x, you can take the log of both sides. Why do we take the log of both sides? It allows us to pull the exponent out in front. And if the exponent is out in front, now you can go and solve your equations just like normal. So we did this in every single one, right? The second one, either you divided first to get the power by itself, or you took a log, but you can only bring that exponent out in front once you have a single power inside of a logarithm. In the last one, we had a single power, the exponents came out in front right away. After that, it's just regular algebra to get x by itself. Although the regular algebra is a little bit weird for you because your numbers are weird. Like natural log of 5 is 1 point something. If you had an actual number here, you'd be like, if this was 3, you'd be like, distributing would be no problem. But as soon as the number looks a little funny, it's harder. But you have to remember, That natural log of 5, natural log of 3, those are just numbers that look a little funny. Okay, so with that, we are ready to go to a question where you can write it down. Example 3. On part A. Can we get the bases the same? Should this be non-calculator? Is 12 in your column of your powers chart with 4? No. So since it's not, we're going to have to use logarithms, and we take the log of both sides. That'll allow us to bring that x out in front. And again, every single time you solve a logarithm, I want you to check to see if your answer is right. Is 4 to the power of x equal to 12? It is. Oh, I didn't write down the answer to 3 decimal places. It says to the nearest hundredth. That's the thing about rounding. You should read the question. If it doesn't say on the exam, you have to go to 3 decimal places. If it doesn't say on the exam and you don't go to 3 decimal places, they take off a half a mark as a rounding error. But if the question itself says something else, and you haven't reread the question at the end, then you lose a half a mark for rounding error that way too. So it really wants you to be careful and read all the way through. Part B. If I was solving this one, I would first say, here's my power. Could I easily get that power by itself? Yes. What would I have to do? I'd have to divide both sides by 3. If you can get the power by itself, you should do that. I'm going to divide both sides by 3. It'll just make your work with logarithms shorter. Now, is 2 and 12 the same column of powers chart? Can we do this without a calculator? No. So we have to take the log of both sides. Sometimes on the final exam, you might be tempted to take the log of both sides and bring the number out in front all at once. Okay? On the exam, they actually give you sometimes a half mark, sometimes a full mark, just for knowing to take the log of both sides. If you take the log of both sides, bring the exponent out and make a mistake, you might lose out on 2 marks. Like 1 mark is easy, just taking the log of both sides. Now, bringing the exponent out in front on the exam, that's another mark. Make sure it's in brackets because it's a binomial. Log of 2 is a number, so you can distribute it. Move the log 2 to the other side, so my x is by itself. And now I can divide. Log of 12 minus log of 2 all over log of 2, 2.5. Again, I'm really curious if I got this one right, so I go to my calculator, I store this answer, and I have 3 bracket 2 to the exponent of x plus 1. If this is right, it should equal 36. And it does. So no longer do you need to check your answer at the back of the book or check the answer key. You should be checking them yourself, right? You should be able to, because this is a really useful tool on the exam. It's also really nice for your confidence on the exam to be like, huh, I checked it and it worked. So I know that it's right. And finally, part C. Are 3 and 6 in the same column of your powers chart? Can this be non-calculator? No. So we have to take the log of both sides. Can we get powers by itself? No, there's powers on both sides. So I take the log of this side. I take the log of this side. These exponents could come out in front. This is a number, so I can distribute it. So now I have 2 terms with x's. So I'm going to want to bring those 2 terms to the same side, and I'm going to try and put all of my terms without x's on the other side. Because then I can factor out the common factor of x. And again, type this into my calculator. One 1.58. And again, I want to know whether or not this is right, so I'm going to store it as x. The original equation on the one side had 3 to the x plus 1. On the other side had 6 to the x. And if these 2 sides are equal to each other, then we know we've done it right. Circle questions 7, 8, 10, and 12.